So this is the grouping method, and like I said, this is going to be used for harder questions like factoring something like this. 4x squared plus 15 plus 16x, something like that. Why is this a harder one to factor? Because 4 has more than one option. 15 has more than one option. So if you tried to do it directly using the technique that we've done, right, this is the technique that we've done so far. If you choose the wrong one to start with, it could take longer, right? Because it's either 4 and 1 or 2 and 2. If you luckily choose the right one to start with, then it's not so bad. Outside and inside, can you see things that make 15 that would make your outside and inside make 16?
3 and 5.
3 and 5. Perfect. And they both be positive, and if we double check it, it works. So just because we have a harder one, sometimes our regular technique for factoring it will be just as fast, especially if you get lucky and chose 2x and 2x and it happened to work. But if you chose 2x and 2x and it was 4x and 1, you'd have to try a bunch of things just to find out they don't work, to say I'm going to start and choose the other idea. So on the ones that takes a long time, sometimes it's nice to have a method that will work for you to figure it out. And this is called the grouping method. So how would I do the grouping method for this question? First of all, it says write down the product of the first and last term. So in our case, the first and last term is a 15 and a 4. That product is 60. And the middle term, it says also write down the middle term, which is 16. And the reason we label the middle term with an S is because now you are going to look for two numbers that multiply to 60, but add or sum to 16. Can you figure out two numbers that multiply to 16?
6 and 10.
6 and 10. Do they add to 16?
Yeah.
Oh, I was hoping you'd pick one that didn't work first, but you guys got
30.
2 and 30. Does that add up to 16?
No.
No. So you're going to have to go through what makes 60. 2 and 30, does it add up to 16? No. But you got 10 and 6, that adds up to 16. So it says look for two numbers whose the product of the one and the other one. So our two numbers are 10 and 6. Then rewrite your equation, but instead of writing 16x, you rewrite it as 10x plus 6x. So what we're actually doing here is, you know when you FOIL and you get your outside and inside and they're like terms? What this technique does is it has figured out what the outside and inside would need to be. They would need to be a 10x and a 6x. Can you see that we now have 4 terms?
No.
I'll do it again. Are you ready? 1, 2, 3, 4. Can you see that we now have 4 terms? You said no the last time, but you might have been talking about something else.
I'm trying to get excited.
Okay. So we now have 4 terms. If you look at them in pairs, the first 2, do they have a common factor?
Yes.
What is it?
2.
And?
Well,
2 for sure. Do they have anything else in common?
X.
An X. So in the first 2, you have a 2x that you could pull out. If I pull out a 2x out of this one, I'd be left with 2x plus 5. Agreed? Yep. Now look at the last 2. Is there something in common in the last 2? There's a 3. So there's a plus sign, plus 3. and then you'd be left with 2x plus 5. You're lost? We had 4, and we just looked in the first 2 if there was something in common, and we did common factoring, pulled out a 2x. And then we looked in the next 2 if there was something in common, it was also 2x. And if the group, what happens with the grouping method is now, do you see that there's a 2x plus 5 and a 2x plus 5 there? So we can do a common factor again. If we think of this as one term and this as one term, and they both have a 2x plus 5, you could pull a 2x plus 5 out. If I pull a 2x plus 5 out, if I pull a 2x plus 5 out of the green box, what's left? A 2x. If I pull a 2x plus 5 out of the second green box, what would be left?
3.
Plus 3. Notice that oh, yeah, there we go, is the same as what we found when we factored using our old technique. And if we multiply it out, it works out perfectly. This is called the grouping method. The grouping method is quite a bit longer than the factoring methods we've done so far, but sometimes is faster if you have a hard question to begin with. Okay, we're going to do some more. Okay, we've seen one example. At this point, you probably shouldn't get it yet because you've only seen it happen once. But let's zoom out here so we can see the whole thing all at once and recap what we did. So you have one, 4x squared plus 16x plus 15. It looks like it would be hard using your old technique. So you decide you want to use the grouping technique.
On the quiz, are we going to get a calculator?
I think this quiz will be a non-calculator quiz. Although I'll have to look at it. Maybe I put some big numbers on there that I'd let you use. But be prepared for it to be non-calculator. Okay, so re-looking at the method. We have one that looks like it's going to be hard to factor. So we multiply the coefficient of the x squared times the constant, the first and last terms, 4 times 15, we get a product of 60. We also write the middle number down, sum is 16. Then you go through the things that multiply to 60 until you find one that also works for the sum. So you could have tried, ooh, if the sum was 17, what would the two numbers be? 12 and 5. Ooh, that's a good one. Right? 12 times 5 is 60. But our number is 16, so you'd be like, 12 and 5 doesn't work, but 10 and 6 does. Once you've found those two numbers, you rewrite the original equation, but instead of writing the 16, you break it up to 10x and 6x. And this is like the step when you FOIL this out. Like, can you see that when I FOIL this out, if I wrote everything, I would get a 10x plus a 6x? This is my outside and my inside. It finds out what those outside and inside things were before they were combined. Then, the grouping method says, look at your first two, what do they have in common? Pull that out. Look at your second two, what do they have in common? Pull that out. And then I put green boxes around both of those things. There should be something in common in those green boxes. That was the 2x plus 5. So you know that 2x plus 5 can be pulled out of this green box and pulled out of that green box, leaving you with 2x plus 3 as your second factor. Okay. Go back to page width. So this is definitely more complicated than what we were doing. Because what we were doing was just a lot of mental math to figure things out. Okay? When do you know that you maybe should try the grouping method? And I would actually say overall, try not the grouping method first, right? Try 2 and 3, see if it works. If it doesn't, try 6 and 1, see if it works. You might still find that's faster for you. Perfect. Because if that's faster for you, that's better. Plus, it makes sense how it's done. You don't have to remember a bunch of steps, which is also very nice. Because I can tell you when I talk to my grade 12 students, I'd be like, hey, well, do you remember the grouping method? They're like, and then they can't use it. If you can't remember something, it's very hard to use that, right? Right? If I forget Janae's name, I see her in the hallway, I can't, it's very hard to call her something other than like, hey, you, or hi, and pretend it's awkward if you don't know the name and you try to say the name. Really awkward when you meet somebody and you know them, and they're like, oh, let me introduce you, and you're like, oh, okay. And I need to introduce who I'm with, but I don't remember your name, so I'm like really feeling awkward at this moment. Same thing happens in math. If you forget how to do something, it makes that question awkward and you're stuck. So, if you can do this one directly, using the fact that this is your first one and this is your last one, perfect. But we're going to practice the new method so we get used to it. First of all, we multiply the first and the last term, 6 times 15. 6 times negative 15 gives us negative 9. And then we look at our sum is 1. What two numbers multiply to give you negative 90?
9 and 10.
9 and 10 give you positive 90.
Oh, negative, or positive 10 and negative 9.
Positive 10 and negative 9. Does positive 10 and negative 9 add up to positive 1?
Yes.
Yes, so then your numbers are positive 10 and negative 9. Can you see that positive 9 and negative 10 would still work for the product, but wouldn't work for the sum? Okay? So that where you put the negative is important. Once you've found your two numbers, you rewrite your equation by breaking up the 1 into positive 10x and minus 9x. Can you see what I've underlined here in green is still equal to the original equation? And in some ways, we're kind of like, well, we complicated it more than it was. Before it was simple, and it was simplified. Now we've unsimplified, complified. It's a good word. Okay. But that lets us look at the first pair. Is there anything in common in the first pair? There's going to be a 2 and an x, leaving me with 3x plus 5. Is there anything in common in the second ones? There's a 3. And in the second ones, you have options with your 3. Because you could either say positive 3 or negative 3. Your goal, though, is whatever you pull out, you want this 3x plus 5 to happen again. So if I want this to be 3x plus 5, can you see that I would have to take out a negative 3, not a positive 3? Because a negative 3 out of a 9 would give me positive 3 here. A negative 3 taken out of the 15 would give me positive 5 there. Yes?
If we knew that we just had to like bring the negative down, would we have to know that?
If you knew that you had to bring the negative out, well, like,
Because the stuff before the 9.
yeah, because I would know that, but sometimes you want to take the positive number out and leave the other stuff in there. So you have to think about, so we pulled out the common factor out of the first two, common factor out of the second two, which gave us this big thing in one green box, this big thing in another green box. Is there something in common in those two? Yes, there's a 3x plus 5. So that means if I pull out the 3x plus 5 as a common factor, what's left in the first green box?
2x.
What's left in the second one? And you should now check, Do the first ones work out? Do they give me 6x squared? Do the last ones, do they work? Do they give me minus 15? Do the outside and the inside give me plus 1? So even if you're using the grouping method, you still should FOIL when you're done to check. Okay? If you're using the old technique, do you think you would have gone with 3x and 2x first? Or would you have gone with 6x and x first if you had to?
I just guessed
How did
and I
that
did
work?
3x plus 5, 2x minus 3, and I got the answer.
Well, that's even like, right? The technique of let's just try one that works with first and last and check it. Sometimes you'll get lucky and just guess the right thing right at the beginning. So the old technique is still our best technique. But this is nice, is if your old technique isn't working, you've already spent 2 hours and 70 minutes. That's like 3 hours and 10 minutes. It's not a good exception. A very long time. You've already spent a very long time trying it. You're getting frustrated. Does that ever happen with a math problem?
Yeah.
That you're working on it for a long time and it's not working, so now your frustration is coming in. This at least allows you a technique to get the answer. Okay? But I would tend to say still try the other technique first. So if you were trying the other technique first, you look at that first, you look at this last. And why is this one hard? Well, the first one could be 2x and 2x or 4x and 1x. And the last one could be 9 and 1 or 3 and 3. So if we do the new technique, it says multiply your first and last. What's 4 times 9? 36. So we're looking for a product of 36 and sum of negative 15. What are two numbers that multiply to 36?
6 and 6.
6 and 6. Do 6 and 6 make minus 15? No.
12 and 3.
12 and 3.
12 and 3.
Negative 12
And negative 3.
and negative 3. Nice.
That's right.
Does that multiply to positive 36?
Yes.
Does it add to negative 15?
Yes.
Yes. Okay. So sometimes it's great. I love saying a number that, first number that comes to your head for product, do that, add them up, check. Because finding an answer that doesn't work usually leads you to the answer that does work. So now we would rewrite 4x squared minus 12x minus 3x plus 9. And so what we've done is we have rewritten the minus 15 with minus 12x and minus 3x. Still equal the same thing. Awesome. Thank you. And now we look at the first two. What's in common with the 4x squared and the minus 12x?
4 or 2. 2.
There's a 4. Yeah, 4 works. And
2.
And an x.
3.
4 and an x, leaving me with x minus 3. For the second one, can you see that you would want to take out a minus 3 to get a positive x there? That matches up. Does it work out when you take a minus 3 out of 9? Do you get minus 3? And so this one in common in here and here is an x minus 3. If I take the x minus 3 out, I'd be left with 4x from the first one and minus 3 from the second one. You feel like
Oh, I'm just saying if there's like an easy number for the last one, I probably don't.
yeah, like again, I still would want you to use your main technique first. But the problem here in the main technique is if you did this with 2x and 2x, it's not going to work, right? What could you put here? 3 and 3. You have to do a lot of mental math quickly. If I put 3 and 3 here, do you see my outside, inside makes 6 and 6 doesn't make 15. So I could do 9 and 1. 9 and 1 would give me 18 and 2. That also doesn't give me 15. So that's how long it would take me to find out that 2x and 2x doesn't work. It's not that long. And then I'd go like, okay, so now it has to be 4x and x. And now I would check. I would check 3 and 3. 12 and 3. Oh, it looks like it's going to work. I need a negative 15, so negative 12 minus 3 is minus. Check, get positive 9. That didn't take too long to factor using my old technique. Probably still factoring faster than the grouping method. Again, lots of mental math in the old technique, so the other positive thing is it strengthens your mental math skills. But if you get stuck, it's nice to have a method that works. That's just, I highly, highly recommend that you use the old technique. Okay, that's just I'm telling you that I would highly, highly recommend. Let's just do it. Just to remind ourselves how easy the old technique was. Bracket, 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 bracket. This is your first. This is your last. What has to go first? X. What has to go last?
You have to time bring that equals 15.
No.
12.
You need 36.
Oh yeah, negative.
What things make 36?
Negative 9 and negative 4.
Ooh, so 9 and 4, outside, right? Outside and inside, yes. If they're both negative, that'll give me negative 13. Check it, it works.
Good.
Right? If you did the product and sum, the product here would be 1 times 36, which is 36. The sum, negative 13. And it would be a lot longer. So this one, I would strongly recommend using the first technique. If you didn't, you would still have to find out, oh, the numbers are negative 9 and negative 4. And so you would rewrite x squared minus 9x minus 4x plus 36. What's common in the first ones? Only an x. What's common in these ones? A 4. Wouldn't you agree just doing it directly is way better? Okay, same thing with the next one. Have that star there to remind me, make sure you do it directly first. First, last. What has to be first? 2x and x. So whenever that first one is like a prime number, I definitely say use the old technique because it's faster. Because you only have one option. And now, we need 5 in the end, but we need the outside and the inside to make 11. So you really have only 2 options. It's either 5 and 1, or 1 and 5.
It's not. It's 1
It's
on
positive,
one side
so
and
it would
5
be
on the other.
yeah.
Well, yeah. Which side is your other side?
Plus 1 and plus
the
1.
one with the 2x is with 1,
Yeah, 5
and
Yeah.
then the one with
The
the
other
x
one's
is
plus
with 5.
5.
It has to be that way. Why? Because we need 10 on the outside plus 1 to
And they
make
both
11.
be positive.
And they both have to be positive.
So I'm sorry.
Okay? So again, I would highly recommend this is the way you do this question because it's not hard. But if you go to the longer method, our product would be 2 times 5, 10. Our sum would be 11. 2 numbers that multiply to 10 and add to 11. two numbers that multiply to 10, but when you add them, you get 11. 10 and 1. So if I rewrote this 2x squared plus, ooh, I like this question. I want to show you something interesting in this one. I rewrote the 11x as 10x plus x. And then, what's in common in the 2x squared and the 10x? There's a 2 and an x, leaving me with x plus 5. And I like to show this example this way because this sometimes comes up in a grouping question and students get stuck. They're like, there's nothing in common with an x and a 5. So what do I pull out? A 1. And that 1 is important because now there's an x plus 5 that gets pulled out. What am I left with? I'm left with a 2x plus 1. So I think in the grouping method, not only does it works, but it's longer, and this one has like a little trick, or you get stumped on the fact that there was nothing in common in the x plus 5. So how would you go about that? So the direct method is better.
Do I have permission to put this in the gradient from here?
From there? You have permission, but I don't know if you have the skill.
Airball.
Oh.
Did it go in?
Yeah.
Sweet.
That's cash right there.
Let it hit the edge.
Imagine it go.
Alright, I am going to give you time to work on either your pre-test,
I'll do my best.
because some of you don't have your textbooks with you. If you have your textbook with you, then work on this.